What are factorial notation? There's a button on your calculator that has an exclamation mark. So press 5 that gives you a number, 120. Now, how do they get 120? Let's give you the definition. It means 5 times 4, the product of all the consecutive numbers up to the number 5, which is 120, okay? And then you also have, so basically in general, n factorial is, actually we'll go to 0 factorial first. So now what's 0 factorial? If you use your calculator, it's actually not 0, it's actually 1, okay? You learn why it is 1 later on, but now just accept 0 factorial is 1. Okay, next is n factorial. N factorial means n times n minus 1 times n minus 2 all the way to 3 times 2 times 1. And then you can also express factorial in terms of itself. So n factorial can be written as n times the smaller factorial, n minus 1 factorial. Okay. All right. These are important formulas. Let's. I should highlight some of these. So highlight this one. That will be important later on. And that's the definition of n factorial. And remember, 0 factorial is 1. Okay. Good. Done. Right, after we do this, we need to know how to unroll factorial. So using this formula, we can write 8 factorial in terms of 8 times 7 factorial, right? And then when we get to, I can unroll further, n times 7 times 6 factorial. Or I could write that as 8 times 7 times 6 times 5 factorial. Okay, let's move on to example 6. Right, what's example 6? This example, 10 factorial over 7 factorial. So you do 10 times 9 times 8 times 7. Stop at 7. Why do I stop at 7? Because that cancels. And you can just work this out on a calculator, or you can do it by hand, which is going to be equal to 9 times 8 is 72, 720. Right? Of course, you can do that on a calculator, but we want to learn how to do it without a calculator, so we can understand the algebra of it. All right, same thing for the next one. Change the bigger one. 7 times 6 times 5 factorial times 3 factorial. So unroll the bigger one. The bigger one, the 5 factorial will cancel, and you can do the rest on your calculator. So you just do 7 times 6 times 3 factorial equal to 252. All right, okay, good. Let's continue. Now, why do we need to know this without a calculator? So we can do questions like this, where you can't do it without a calculator. So what you do is this. So you unroll the bigger one. So which one's the bigger one? The one on the top. N plus 2. And then n plus 1. Oh, run out of space. Let's write it below. Sorry. So I'll write it here. Equal n plus 2, n plus 1, and then n, and then n minus 1 factorial. Yeah? So that I could cancel with the factorial at the bottom. That cancels. So you end up with n plus 1, n plus 2. You don't need to expand. I think leave it factorized better. All right, there's another one. Could you try the rest? Have a try the next one. It's very similar, just a little bit more complicated. Okay, good. So unroll the bigger one. So the big one is n plus, or maybe unroll this one. Or there's more than one way of doing. So unroll the top one, so you get n minus 1 factorial. Keep the one on the top the same. And then unroll this one, which is n plus 2, n plus 1 factorial. Okay, so now we can cancel these two. Made it. Okay, these two, and you end up with n over n plus 2. Right? All right, good. We're on page 9 of the notes. All right, continue. Next one. Next one is n minus 1, n minus 2, dot, 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 up to n minus r eventually. And then they can cancel. So you get this. But the question is, what's the term before this? Yeah, just 1 before. So write n minus r, but you just add a 1. So we'll know what the last term. All right. All good. Now we know how to simplify factorial. The next step is to learn a new notation. Okay, so learn a new formula. That will be relevant for the rest of this topic. So we're going to learn this formula, and then we'll do some question on this. All right. All right, hopefully you're all ready. I'll leave it there for a while. Oh, good. Oh, okay. That's good. So, all coming. Okay, that's good. Okay, let's continue. All right. So we're going to learn these new formulas. That's not on the, is that on the reference sheet? I don't think they're on the reference sheet. So you need to memorize this. These formulas need to be memorized. Memorize. Memorize. Is it on the reference sheet? I'll just double check. No. So you have to memorize. Okay, not on the reference sheet. So remember what they look like. We'll do some practice using this formula. So it's very easy to apply. So there's the nCr, there's this notation. You have to know both notation. Well, this is what nCr means. This is what nr means. Okay. Let's use this formula to do it. So you write a factorial. 8 is the n. Then you got the r, which is the 5. 5 factorial. n minus r, 8 minus 5 factorial. And then you simplify that. You can just go 8 factorial over 5 factorial, 3 factorial. And then you just work out. Or you can just do it on a calculator. So you do fraction, 8 factorial, 8 exclamation mark, 5 factorial, 3 factorial. That will be, oh, it didn't work. Oh, times. Put a times. Yeah, you need to put a times. 56. Okay. Now, you can actually do the whole thing on a calculator. There's this button here that you can press. So you can write 8C5. Now, there's a C button on your calculator. Can be found by doing 8, shift, divide. Shift, divide to get C. See the C there? 5. Give you 56. Okay. Let me write it down for you. Write 8, shift, divide, and then 5 equal. And you should get 56. Okay. So this button here, divide, shift, divide. Of course, that doesn't work if it's a polynomial. So we need to do the calculation by hand. So let's try to simplify this. n3. So you go n factorial, 3 factorial, n minus 3 factorial. Okay. So how would that work? You'll get n factorial, 3 factorial. Unroll the, actually you need to unroll the top one. I just wrote it again. So let's unroll the top one. n minus 1, n minus 2, n minus 3 factorial. That will cancel the bottom bit. So, and then we can work out what 3 factorial is. 3 factorial should be 6. So you write 6 at the denominator. n minus 1, n minus 2 over 6. Okay, good. All right, so we're done. One more page, then we finish. We're now going to look at some properties of this new formula. There's some interesting property about it, and it's related to the Pascal's triangle. which you will learn later on. Okay, so we're going to continue that. Some symmetrical properties. 7C2, 7C5. How do I know this? We can check on a calculator. 7C2 is 21. 7C5 is also 21. And why are they equal? Using the formula, which I'll write over here, r factorial n minus r factorial. And then what you do is, if you use the formula, you get 7 factorial over 2 factorial, 5 minus 2 factorial. Agree? And how about the other one? You get 5 factorial, but you get 5 minus 7 minus 5 factorial. They look a bit different at first. So if you look at it more closely, they got the same numerator first. But the denominator actually the same. This is, actually that should be 7, not 5. Okay, so therefore you can see that this is 5 factorial, 2 factorial. This is 5 factorial, 2 factorial, which is switched around, isn't it? Right? So you'll see that they are the same as long as the 2 and 5 adds up to the n. Adds up to 7, they will be equal. So in general, that you got this formula. nCn minus r is same as nCr, because if you do that at the bottom, that will be n factorial n minus r factorial. This will be n minus r factorial. And this simplifies to be n factorial n minus r factorial, which is the nCr. Okay? So this is a general formula, so you should highlight that. That's a very important property. And then you can also express it using the notation I showed you before. This is a new notation, just different notation. Okay. All right, and then we're going to look at some particular values, and then write above rules using nCr. Okay, good. All right, let's do that. Okay, let's look at some particular values. nC0, n factorial is over 0 factorial, n minus 0 factorial. Now, what's 0 factorial? 1, n factorial over 1 times n factorial, which is just 1, right? So nC0, regardless what n is always equal to 1. Whereas nC1, if I use the formula, becomes 1 factorial n minus 1 factorial. That if we unroll the top, it will cancel. So you will see these two cancel, so you end up with n. So nC1 always equals to n. That's a useful one to know. And then finally we've got nC2, which you can simplify. Now nC2 will be a bit more complicated, so we may not learn the formula. So you just unroll it. Alright, so if you unroll, so that will give you this. That will give you half of n minus 1, which gets more complicated as you increase the lower values. So now we have these values. Combining with the symmetrical properties, we have the formula below. Okay? Okay, let's take a rest. Yeah, come back in 20 minutes. Thank you. All right, nC0 now, using the symmetrical property, remember this symmetrical property, nCn equal to nCn minus r equal to nCr. So nC0 is same as nCn, so they're both equal to 1. And nC1 and nCn minus 1 equals to n, right? So now we have 4 free values. And then I want you to write this result using the NR notation. So using the NR notation, we can write that as N0 equal to NN, both equal to 1. This one you can write it as N1 equal to NN minus 1, also both equal to N. So you need to be familiar with both notation, the nCr notation and the nr notation. Okay. Let's put this rule into practice. We'll fill in the table below. All right. Try to do the following without a calculator, using the rules above. All right. What would the first one be? 15 0 will be 1. Every time you see 0 is 1. 15 1, you get 15 because you get n. Now, why do I want you to do this? Because it's much slower to do it on a calculator, isn't it? If I do 15C 0, that's like a lot of buttons to press before I get 1. If I do 15 1, I have to go 15C 1 to get 15. But if you remember this formula, that will make it easier for yourself. How about the next one? So when it's 1 less, 13C 12, when it's 1 less, is equal to n. So equal to 13. Right? So 1 less or 1 gives you the same answer. How about the next one? 9 8 will be 9. Very good. 20 20, when they're the same, 1. All right. And of course, get familiar with the C formula. 5C5. 5C5. William, 5C5. Yeah. 5C5, have a try. Look at this rule. 5C5, look. 5C5 is equal to 1. Right? Okay, good. Right, Mitchell, 21C20. 21, very good. L, 3C0. 1, good. Tilly, 23C1. Yep, you all know this. Very good. Jessica Ma. Last one. Okay, well, got it. Excellent. All right, so you can do the homework from exercise 5. Is it 5B? Yeah, 5B. 5C today. We'll skip 5B. Okay? Do exercise 5C today. Thank you. I'll give you